Welcome to Math with Father. Welcome to Math with Father. Subscribe, like and share.
Today, we have a very nice exponential equation. 4 multiplying the bracket 4 raised to the power x minus 2 raised to the power x bracket close plus 1 equals 2 raised to the power x. We need x. We are finding for x. So let's delve right into this. Now, the first thing to do is to expand our bracket. 4 multiplying 4 raised to the power x minus 2x by 4 plus 1 equals 2 raised to the power x. Alright, now we have 4 multiplying 4 raised to the power x, and they all bear the same base. So one of the base is written and the powers are added because of this multiplication sign. Minus 2 raised to the power x by 4 can be written in an index form, which is 2 raised to the power 2 plus 1 equals 2 raised to the power x. 4 raised to the power x plus 1. Okay, so here I have 2 raised to the power x at my right hand side of the equation, so I can take the whole of this expression to the other side of this equal sign, plus 1 equals 2 raised to the power x plus 2 raised to the power x by 2 raised to the power 2. I'm repeating this equation. Okay, 4 raised to the power x plus 1 equals 2 raised to the power x plus 2 raised to the power x. I'm simplifying this to 1 or to 1 form by 4. 4 raised to the power x plus 1 equals, here we have a common index form, which is 2 raised to the power x. 2 raised to the power x is factored out by, so we have 1 plus 2x out, we have 4. 4 raised to the power x plus 1 equals 2 raised to the power x, 1 plus 4, 5. 4 raised to the power x plus 1 minus 2 raised to the power x by 5 plus 1 equals 0. So let's move back and then check. 4 raised to the power x plus 1 minus 2 raised to the power x by 5 plus 1 equals 0. Okay, so with this, 4 can be written in an index form, which would be 2 raised to the power 2 multiplying x plus 1 minus 2 raised to the power x by 5 plus 1 equals 0. So let's keep on simplifying. We have 2 raised to the power 2x plus 2 minus 2 raised to the power x by 5 plus 1 equals 0. 2 raised to the power 2x. I'm expanding this exponential form by 2 raised to the power 2 minus 2 raised to the power x by 5 plus 1 equals 0. Okay, now 2 raised to the power 2 is 4. So we have 4 multiplying 2 raised to the power 2x minus 2 raised to the power x by 5 plus 1 equals 0. 4 by 2 raised to the power 2x minus 2 raised to the power x by 5 plus 1 equals 0. Okay, so back in the laws of indices, which is the third law, the power law, that anytime we have a raised to the power 2x, we have a power 2 multiplying another power x, and this could be written as a raised to the power x or raised to the power 2, and we are going to change this to the form of this. Now 4 into bracket 2 raised to the power x by 2 minus 2 raised to the power x by 5 plus 1 equals 0. So here we have a common exponential term which cuts across all the terms, and that term is 2 raised to the power x, 2 raised to the power x. We have 2 raised to the power x here at the constant term. So we are going to equate 2 raised to the power x to a different variable. So we are letting u be equal to 2 raised to the power x. Now we substitute in u. 4 by u all squared minus u by 5u plus 1 equals 0. 4u squared minus 5u plus 1 equals 0. So now we've gotten our proper quadratic equation of the form ax squared plus bx plus c equals 0. So we are going to simplify or expand this quadratic equation. Now we are going to find for the product and the sum of roots. So with the product, we multiply the coefficient of x squared. Here is u squared, which is a, and it's also 4, by the constant term c, which is 1. The result is 4. And with the sum, we are going to find two common terms from this product. When added, we would be getting negative 5. So we have negative 4, negative 1. Negative 4, negative 1 gives us 4, and negative 4 plus negative 1 gives us negative 5. We are going to substitute in negative 5 as negative 4, negative 1. 4u squared minus 4u. So since negative 5 is with a variable u is attached to these factors, minus u, which is negative 1, plus 1 equals 0. We group them into factors, minus 4u plus minus u plus 1 equals 0. Now we factor the common thing out. We have 4, we have 4, we have u, we have u. So 4u out, u minus 1, negative 1 out, u minus 1 equals 0. So here we combine 4u minus 1, and we have two common factors, which is u minus 1, u minus 1, and one of it is taken. 4u minus 1 as one factor, and u minus 1 as another factor equals 0. Now we find the zeros of our factors. 4u minus 1 equals 0, u minus 1 equals 0. 4u equals 1. We want u but not 4u, so divide through by 4, minus 4. Now u gives us 1 on 4. On the other hand, u is equal to 1. But from the question, we were asked to find x, but not u. So let's move back to where x was set to the variable u. Okay, so here, anywhere we find u, we are replacing it with 2 raised to the power x. So let's move. We said let u be equal to 2 raised to the power x. So here we have u to be 1 on 4. 2x will be equal to 1 on 4. From here we have u to be 2x, so we will replace it 2x to be 1 on 4 as 1, and we have u to be equal to 1. 2 to the power x is also equal to 1. Now this can be simplified, which is 2 raised to the power x equals 1 on 4 can also be written in an index form that would be 2 raised to the power 2. And this is a fractional index and can be written this way: 2 raised to the power x is equal to 2 raised to the power negative 2. Now here the bases are the same. So the exponents are equated. X is equal to negative 2. Let's move on to the other side, which is 2 raised to the power x equals any number raised to the power 0 is 1. So a raised to the power 0 is 1. 2 raised to the power 0 is 1. And since we want to make the bases the same, 2 is taken as our base and 0 as our exponent, which is 2 raised to the power 0. That's 1. So 2 raised to the power 0 is equal to this one. And since the bases are the same, we equate the exponent. Now x is equal to 0. And these are our solution sets, which is therefore x is equal to the smaller first, negative 2, or x is equal to 0. So these are the x values for this SAT question. These are the x values of this SAT question. X is equal to negative 2, x is equal to 0. Now let's test the values of x to ascertain whether what we will be getting at our left hand side of the equation will be equal to what we will be getting at the right hand side of our equation. Now 4 by 4 x, let's start with 0. 0, 4 raised to the power 0 minus 2 raised to the power 0, bracket close, plus 1 equals 2 raised to the power 0. 4 by 4 raised to the power 0, that's 1, minus 2 raised to the power 0, that's 1, plus 1 equals 2 raised to the power 0, that's 1. 4 by 1 minus 1, that's 0, plus 1 equals 1. And 4 by 0 is 0, plus 1 equals 1. And 1 is equal to 1. So meaning x equals 0 is a solution to the answer, and that is right. Let's check for the second one, which is 4 raised to the power 4 multiplying 4 raised to the power negative 2 minus 2 raised to the power negative 2 plus 1 equals 2 raised to the power negative 2. 4 by 4 raised to the power negative 2 is 1 on 16 minus 2 raised to the power negative 2 is 1 on 4 plus 1 equals 2 raised to the power negative 2. Now in simplifying this, the LCM would be 16, right? So we have 4 by 16 into itself 1 into 1 1 minus 4 into 16 4 by 1 4 all on 16 plus 1 equals 1 on 4, which is 2 raised to the power negative 2. Let me continue somewhere here. 4 by 1 on 4 all on 16, which was our LCM, plus 1 equals 1 on 4. Okay, so let's simplify the bracket. 4, 1 minus 4 all on 16. 1 minus 4, that will be negative 3 on 16 plus 1 equals 1 on 4. We have 4, 4 into itself 1, 4 into 16, 4. Now, we have negative 3 on 4, which is negative 3 on 4 plus 1. So let's do this part to find out whether we'll be getting this equals 1. So every whole number is divided by 1, and our LCM would also be 4. Alright? 4 into itself 1 by negative 3, negative 3. 1 into is 1 into 4, 4 by 1, so plus 4. Negative 3 plus 4 giving us 1 on 4. So we have 1 on 4, which is equal to 1 on 4, and x equals negative 2. X equals negative 2 is also a solution to the question. This was a such question, and most of the students found it difficult to solve this question. So we've taken our time to dissect, and integrate this exponential equation. So if this video was very helpful, give me thumbs up by clicking on the subscription button, like the video, and put me on post notification anytime I post new video. Thank you for watching and building this channel as a family. Thank you for your time. I'm out.
Subscribe, like and share.